Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Well, introduce myself. My name is Namra Sarwar. I am from BS Chemistry. Now, today my topic is bonding trends. Table of content. Bonding trend, inert pair effect, periodic trend illustrated by hydrides, types of hydride, periodic trend illustrated by oxides, types of oxides, and the last one is hydrogen. First, I'll explain bonding trend in front of you. The points to keep in mind about bonding trends are therefore. First point, element in period 2 form the number of electrons in the valence shell and the octet. For example, carbon with 4 valence electrons commonly forms 4 bonds and oxygen with 6 valence electron and therefore needing to more to complete its octet typically forms 2 bonds. Second point, elements in periodic 3 and higher periods can have higher valencies that the octet rule suggests. These elements have access to empty d orbitals and can use them to expand their valence shell past the usual octet of electrons. They also have atoms large enough to bond to more neighbors. Third point, the inert pair effect is a tendency of the two electrons in the outermost atomic s orbital to remain unshared in compounds of post-transition metals. For example, the p block elements of the fourth, fifth, and sixth period come after d block elements, but the electrons present in the intervening d and f orbitals do not effectively shield the s electrons of the valence shell. Inert pair effect. The phenomenon of electrons remaining paired in valence shell is called inert pair effect. It is the reluctance of the s electrons of the valence shell to take part in bonding. It occurs due to poor or ineffective shielding of the ns2 electron of the valence shell by intervening d and f electrons. It increases down the group and thus the lower elements of the group exhibit lower oxidation states. Next, I discuss periodic trend illustrated by hydrides. The hydrogen under certain reaction conditions combine with almost all elements except noble gases to form binary compounds called hydrides. For example, trimethyl silyl. Types of hydrides. The hydrides are classified into three categories: ionic hydrides, covalent hydrides, metallic hydrides. First, I discuss saline hydrides. Saline or ionic hydrides are defined by the presence of hydrogen as a negatively charged ion H negative. The saline hydrides are generally considered those of the alkali metals and the alkaline earth metals, with the possible exception of beryllium hydride and magnesium hydride. These metals enter into direct reaction with hydrogen at elevated temperature 300 to 700 Celsius into 570 to 1300 Fahrenheit to produce hydride of the general formulas MH2. Lithium plus hydrogen atom react with lithium hydride 1689 into 1596. Barium plus hydrogen atom react barium hydride 1402 1343 react with barium hydride 1413 into 1334. Boron hydride 1252 into 1190 react with trimethyl diborane 1744 into 1757. The hydride ion in the saline hydride is a strong base, and these hydrides react instantly and quantitatively with the hydrogen ion from water to produce hydrogen gas and the hydroxide ion in solution. H plus H2O react with H2O plus OH. Because slide hydrides react vigorously with water, giving off large volume of gaseous hydrogen, this property renders them useful as light portable sources of hydrogen. Covalent hydrides. Covalent hydrides are primarily compounds of hydrogen and non-metals in which the bonds are evidently electron pairs shared by atoms of comparable electronegativities. For example, most non-metal hydrides are volatile compounds held together in the condensed state by relatively weak van der Waals intermolecular interaction like methane, ammonia, hydrogen chloride, hydrogen sulfide. Covalent hydrides are liquid or gases that have low melting and boiling points, except in those cases, such as water, where their properties are modified by hydrogen bonding. For example, NH3, H2O, and HF are held together in the liquid state primarily by hydrogen bonding. The hydrogen compounds formed with the elements that follow oxygen H2S, H2Se are all volatile toxic gases with repulsive odors like covalent bond and hydrogen bond. Metallic hydrides. The transition metal and inner transition metals from a large variety of compounds with hydrogen. Metallic hydrides are formed by heating hydrogen gas with the metals or their alloys. Metallic alloy-like hydrides possess some of metals such as luster and strong electrical conductivity. Metallic hydrides essentially consist of protons, positively hydrogen ions, and metals atoms in an electron sea. I will explain previous page. You look at this example. Next, I explain periodic trend illustrated by oxides in front of you. All the main group's elements except the noble gases react with oxygen like hydrides. The resulting oxides reveal periodic trend in the elements. The trend in bonding type is from soluble ionic oxides on the left of the periodic trend table through insoluble high melting point oxides on the left of the P block to low melting point and often gaseous molecular oxides on the right. Metallic molecular elements with low ionization energies, commonly basic ionic oxides. Many oxides of known metals such as CO2, NO, and SO3 or gaseous molecular compound most can act as Lewis acid because the electronegativity oxygen atoms withdraw electron from the central atoms, enabling it to act as an electron pair acceptor. Oxides of nonmetals that react with typically from acidic solutions and hence are called acidic anhydrides. Even oxides that do not react with water can be recorded as a formal anhydride of acids. A formal anhydride of an acid is the molecule obtained by striking out the element of water from the molecular formula of the acid. Types of oxides. Many acids and alkalis are formed by dissolving oxides in water. There are four types of oxides: acidic oxides, basic oxides, amphoteric oxides, neutral oxides. Look at this overview. Elements in two categories: metals and non-metals. Metals involved in basic oxides and amphoteric oxides. Non-metal involved in acidic oxides and neutral oxides. Acidic oxides. Acidic oxides are formed from non-metals. They are usually gases at room temperature and dissolve in water to form acidic solution with pH less than 7. For example, carbon dioxide plus water react with carbonic acid. Acidic oxide react with alkalis to form a salt and water. For example, carbon dioxide plus sodium hydroxide react with sodium carbonate. Important acidic oxides do not react with acids. Basic oxides. Oxides of metals are called basic oxides. Most basic oxides are insoluble in water. Certain basic oxides, for example, sodium oxides, potassium oxides, and calcium oxides, dissolve in water to form alkaline solutions. Basic oxides are solid at room temperature. Basic oxides react with oxide to form a salt and water. For example, calcium oxide plus hydrochloric acid react with calcium chloride plus water. Amphoteric oxides. Amphoteric oxides are metallic oxides that react with both acids and alkali to form salt and water. For example, zinc oxide, acid plus sodium hydroxide, alkali react with zincate sodium zincate salt plus water. Zinc oxide react with both acids and bases to form salt and water. Zinc oxide alkali plus hydrochloric acid react with zinc chloride salt plus water. Neutral oxides. Neutral oxides do not react with acid or alkali. Neutral oxides are insoluble in water. For example, water, carbon monoxide, nitric acid. Nitric oxide. Oxide X. Basic are amphoteric oxides soluble in acid, but acidic or neutral oxide no soluble in acid. Basic oxides no soluble in alkali, but amphoteric oxides soluble in alkali. Acidic oxide no soluble in alkali, but neutral oxide soluble in alkali. Hydrogen. Hydrogen is widely considered to be fuel of our future, and so its properties are of great interest to scientists and engineers. It occupies a unique place in the periodic table. Although a hydrogen atom has the same valence electrons configuration as atom of the group 1 element ns1 and forms plus 1 ions, the element has a few other similarities to the alkali metals. If you have any question about the topic now, I will answer them. Thank you so much.